Hi guys, I trust that you're feeling well and awesome. Welcome to this video on grade 12 mathematics, and in this video we'll be having a look at differential calculus and we'll be specifically looking at the derivative. Now this is the second video in a series of videos that covers grade 12 differential calculus. If you have not checked out our first video yet, I would highly suggest that you have a look at the first video, which covers the topic of limits. I will leave the link in the description below. Once you've seen that video and you understand the concept of limits, you can come back to this one and then we talk about the derivative. For those of you who've already watched it, let's move on. So in this video, we'll be discussing the average gradient of a curve. Then we'll look at the gradient of the tangent to a curve and we'll see actually how these two differ. What's the difference between the two of them? Lastly, we'll have a look at the main subject of the video, which is the derivative. So stick around until the end and you'll get to understand what this derivative is that we keep on talking about. So let's talk about the average gradient of a curve. Now in previous grades, you got the formula for the gradient, or you learned that this would be the formula for the gradient. But now, you've been using this only in the case of a straight line. We also said that if we have 2 points on a curve, let's say for instance this is point A and this is point B, we say we can calculate the average gradient between the 2 points using exactly the same formula. Now why do we refer to it as the average gradient? Well, think about it. A and B do not lie on a straight line. This is a curve. However, we can construct a straight line between the two, and then we can calculate the gradient between the 2 points on that specific straight line that we constructed. But now let's say for argument's sake that we had a point C here that lies between A and B. You will notice that the gradient of AC is not the same as the gradient of BC. In fact, on a curve, the gradient changes all the time depending on which point you're looking at. And that's what we're going to look at in the next section once we start talking about the gradient of the tangent. Nevertheless, if we are given 2 points which are a distance of h units apart horizontally, we can calculate the gradient using a little bit of a different formula, and this is the formula that we can use. Now let's actually go to the writing pad and let's try and understand what's happening here, how we came about with this formula. So let's assume that you have a curve. Any type of curve would do. Whoops, that is not a curve. Let's say there we have a curve. And let's say for argument's sake that we've got point A here. Now, we've got point B, let's say somewhere here. There's point B. What we're actually saying is that there is a horizontal distance between the 2 points. And let's just indicate that we're looking at a horizontal distance. So we have got a horizontal distance between the 2 points of h. Now let's talk about this. If we have the coordinates of A as x and f of x, remember, if we have a horizontal distance, we can get the x coordinate of B by saying, okay, the x coordinate of B is the x coordinate of A plus h. Then to get the y coordinate, we take this same x coordinate and substitute it into the equation of the graph, whatever the equation might be. In this case, it's going to be f of x plus h, assuming of course that the curve has some type of an equation f. I hope that this makes sense. Now, let's calculate the gradient. The gradient of AB, when we use the normal gradient formula, we will get this is y2 minus y1 divided by x2 minus x1. Or you could say y of b minus y of a divided by x of b minus x of a. So this is going to be y2, this is going to be, this is x2, this is going to be y1, this is going to be x1. Now let's see what we would come up with if we substitute these coordinates into our equation. So for y2, this is going to be f of x plus h, minus y1, which is just f of x. And all of this is going to be divided by x2, that's x plus h, minus x1, which is just x. Now notice, we've got positive x and negative x. The x's will cancel out, and then you remain with the equation f of x plus h minus f of x, everything divided by h, which is exactly what we saw in the notes previously when we said that we could use this equation to calculate the gradient between 2 points. I hope that this makes sense. Now, this only still applies if we are working with 2 points. Would it be possible for us to calculate the gradient at only 1 point perhaps? Let's look at it. We can have the gradient of the tangent. Now before we continue, let's just clear something. A tangent, what do we know is a tangent? You might be thinking a tangent is a straight line that touches the circle at 1 point. That's absolutely true. When we're looking at calculus and functions, the tangent is actually a straight line, just like in the case of a circle, but the only difference is the straight line touches the curve once. So we are looking at a curve here instead of a circle. It is a straight line that touches the curve once. Now, because this is a straight line, remember, you can still think of this as y equals to mx plus c. But we'll talk about the rest a little bit later on in another video, where we go into detail with determining the gradient and the equation of a tangent. But for now, we set the problem with the equation that we got in here is that it only utilizes 2 points. And as we've already mentioned, that the gradient on the curve changes at each and every point, 1 point. Now what we could do is we could calculate the gradient of the tangent to the curve, meaning that we are calculating the gradient at only 1 point. And we could do this by taking the equation that we have in the previous slide, and we find the limit of that equation as h approaches 0. So we are saying that if we take this equation that we have so far, the gradient we said is equals to f of x plus h minus f of x divided by h. What we could do here is we could say, okay, to get the gradient at 1 point, let's actually take the limit as h approaches 0 of f of x plus h minus f of x divided by h. And this is the equation that we would use to calculate the gradient of the tangent. In other words, we are calculating the gradient of the curve at only 1 point. I hope that this makes sense. So let's get back to the notes. We said that we can find the gradient of the tangent using exactly the formula that I've highlighted now. We take the formula that we've had in our previous slide for the gradient between 2 points, then we just take the limit as h approaches 0. Now, let's get into the main subject of today's video, which is the derivative. Now, the derivative of a graph f of x, assuming f of x is any type of graph, the derivative can be written as f prime of x. The derivative helps us to calculate the gradient of the tangent to a curve, and it also helps us get the rate of change of a function at a specific value. This is the definition of the derivative. Now, there's a formula that we need to remember, there's a formula that we need to know to calculate the derivative or to determine the derivative. And that formula is highlighted right below. So f prime of x, remember we said f prime of x, this is our derivative. So to calculate the derivative of f, we take the limit as h approaches 0 of f of x plus h minus f of x divided by h. Please make sure that you're familiar with this formula because you're going to be using it in your exam. There's always one question where you have to find the derivative and you have to apply this formula. This formula has a special name. It is also known as the first principles. Now, enough theory. Let's actually do some exercises on the concept of the derivative. So, the first question says we need to find f prime of x, the derivative from the first principles. So we're given f of x is equals to x squared minus 2x plus 1. Let's go to the writing pad and let's have a look at this. So, first of all, let me open a new sheet of paper. We are given that f of x is equals to x squared. Let's see what we had. That's x squared minus 2x plus 1. So x squared minus 2x plus 1. Now, since we were told that we're calculating from the first principles, that should tell you the formula that must come to mind is that f prime of x is equals to the limit as h approaches 0 of f of x plus h minus f of x divided by h. So, We already have f of x. That's sorted. Let's first calculate f of x plus h before we can make use of this formula. So, f of x plus h. Let's think about this for a moment. We said that f of x, the notation of f of x basically helps us to say we are defining a function of x. If I have f of 3, for instance, it means in our equation, where we see x, we just have to substitute it with 3 to get our answer. Now that's exactly the same thing we're going to do here. Where we see x in our equation, we're going to substitute x plus h. So let's look at this. We are going to have x plus h all squared minus 2 into x plus h plus 1. Now we need to simplify our brackets. This is going to be, if I simplify this, I will get x squared plus 2xh plus h squared. Then minus 2 times x, that's minus 2x. Minus 2 times h, that's minus 2h plus 1. Do we have any like terms? No, we don't. But now we have the value of f of x plus h. We can now substitute it into our equation. So let's first start by writing the equation down. So f prime of x is equals to the limit as h approaches 0 of f of x plus h minus f of x divided by h. So this is going to give us the limit as h approaches 0 of, for f of x plus h, we need to put this in brackets, x squared plus 2xh plus h squared minus 2x minus 2h plus 1 minus f of x. Remember, we were given the value of f of x, so this is going to be x squared minus 2x plus 1. Then what we need to do is we need to divide everything by the value of h. Notice that since we don't know what the value of h is, or let me rather say, since we cannot yet substitute h is equals to 0, we need to keep the limit sign. Only when we substitute h is equals to 0, that's when we take away the limit sign. So this is going to be the limit as h approaches 0. Now remove the brackets. We've got x squared plus 2xh plus h squared minus 2x minus 2h plus 1. Then this is going to be minus x squared plus 2x minus 1. And once again, all of this is divided by h. Perfect. When you did things correctly, if you did things correctly here, you would notice that the terms that do not have h as a coefficient will cancel out. In other words, x squared will cancel out with negative x squared. Negative 2x and positive 2x will cancel out. Positive 1 and negative 1 will cancel out. If your terms that do not have h as a coefficient, if they do not cancel out, it means you did something wrong. So let's write down what we remain with. 2xh plus h squared minus 2h divided by, this is divided by h. Now when you get to this point, you will notice that we have a common factor. So we could take out a common factor on the numerator. So this is the limit as h approaches 0. Our common factor is h. We remain with 2x plus h minus 2. And this is divided by h. When you get to this point, h and h will cancel out. You will remain with the limit as h approaches 0 of 2x plus h minus 2. Now that our denominator of h is gone, we could substitute h is equals to 0. This will give us 2x plus 0 minus 2, which is just going to give us 2x minus 2. Wonderful. Life is great. I hope that this made sense to you guys. I know it's a bit of a lengthy process, but it's definitely worth it considering the fact that this question could easily be around 4 or 5 marks. Let's look at the next question. So, in the next question, we've got f of x equals to 2x minus 4. Let's have a look at this. So, I'm going to put this on a new sheet of paper. We've got f of x is equals to 2x Let's just check this out again. 2x minus 4. Once again, what we need to do is we need to make sure that we first write down f of x plus h. So f of x plus h, meaning where I see x in the equation of f, I have to put x plus h. This is going to be 2 into x plus h minus 4. If you multiply out the brackets, you will get 2x plus 2h minus 4. Right. Now we can get back to calculating our derivative. So f prime of x is equals to the limit as h approaches 0 of f of x plus h minus f of x divided by h. Now we substitute. So this is equals to the limit as h approaches 0 of, for f of x plus h, we said we've got 2x plus 2h minus 4 minus f of x, which is 2x minus 4. And then all of this divided by h. Perfect. Our next step is to remove the brackets. So we've got the limit as h approaches 0 of 2x plus 2h minus 4 minus 2x plus 4, all divided by h. Once again, when you get to this point, the terms that do not have h as a coefficient will cancel out. 2x minus 2x cancels out. Then we've got negative 4 plus 4, they cancel out. We remain with the limit as h approaches 0. Notice that we only remain with 2h divided by h. Your h's will cancel out. You will remain with the limit as h approaches 0 of 2. And if you can remember, we said in the previous video of limits, that if we have a limit of a constant, the answer would just be the constant as is. And there we have it. Life is great. I hope that this made sense to you guys. Let's look at the next question. So, the next question wants us to find the derivative of 2 over x. So let's look at this one. And this is an interesting one. So, we are given f of x is equals to 2 over x. We said the first thing we need to do is we need to write f of x plus h as, this is 2 over x plus h. What I'm actually going to do is, before substituting anything into the formula, I'm going to do this separately. I'm going to calculate what f of x plus h minus f of x is. And the reason for doing this separately is that you will see that it becomes a bit messy to substitute fractions inside fractions. So this is going to give us 2 over x plus h minus 2 over x. If you can remember from primary school, whenever we have two fractions which are adding or subtracting with different denominators, we need to find the LCD. In this case, our LCD is going to be the product of the two denominators, so that's going to be x into x plus h. So let's put our denominator right there, x into x plus h. Then what we need to do now is we need to simplify this. So in simplifying this, you would remember from primary school, we said, okay, let's take our first denominator and we divide it by the LCD. So let's see. In fact, we take LCD divided by the first denominator. Our first denominator is x plus h. This is going to give us, that's going to cancel that, we just have x. We then multiply it with the numerator. So multiply by 2, this is going to give us 2x. I'm going to put the 2x there, minus. The next step we need to take is, we need to take our LCD divided by the second denominator. So x into x plus h divided by our second denominator, which is just x. The x's will cancel out, you remain with x plus h. We multiply this with the numerator that we have. This is going to give us 2 into x plus h, which is just going to be 2x plus 2h. So I'm going to substitute in brackets 2x plus 2h. we may as well simplify this while we're at it here. So we will see that the 2x and the minus 2x cancel out. We just remain with minus 2h over x into x plus h. Perfect. Now that we have this, we can now calculate our derivative. So the derivative of f of x is equals to the limit as h approaches 0 of f of x plus h minus f of x divided by h. Already we calculated what f of x plus h minus f of x is, so we could just write the answer that we got there. Our answer was negative 2h over x into x plus h all over h. Now this is not looking too good. So what we can do is let's clarify this fraction over fraction story. This is going to be negative 2h divided by x into x plus h. Multiply by 1 over h. You will see that the h's will cancel out, and what we remain with is the limit as h approaches 0 of negative 2 over x into x plus h. We can now substitute h is equals to 0. We will get negative 2 over x into x plus 0, which is just going to give us negative 2 over x squared. This would be our derivative. I hope that this makes sense to you guys. I hope you enjoyed the video and that you understand the content and that you have a clearer understanding now of using the first derivative in the event that you didn't understand it. If you did understand, please give us a like, give us a thumbs up, please subscribe to the channel. Most importantly, please share the knowledge with other people so that they can benefit from the same knowledge that you're experiencing and learning from here. Until we meet again, enjoy the rest of your day. Ciao.